Good day, everyone. I'm Vincent. In this video, I will introduce you to a study that we did with my colleague from the University of Melbourne, Ronal Singh, Newn, and Denny Oetomo. And in that study, we actually looked at a gazed informed movement intention model, so predict the movement intention. And we propose as well an evaluation, first experimental evaluation of this model. The goal being to use this model for neurorehabilitation upper limb robotics, where we assist people in neurorehabilitation process. So why detecting movement intention is important in that case? That's what we'll start looking at. When we talk about neurorehabilitation, the goal is to restore the sensory motor loop through mass practice, and that can be done with the help of robotic systems, which is shown to be somewhat useful in that extent. And the movement intention, so where and when the patient is actively trying to do the movement, is important to preserve the patient movement freedom and his involvement in the task to restore that sensory motor loop, as well as for the robotic system to provide a suitable assistance. A lot easier, obviously, for the robot to provide a good assistance if it knows where and what the patient, what the patient is trying to do. So the question is, to what extent we can use gaze information, so where we look at, to inform this movement intention and so provide a natural interaction for the patient with the robotic system. That's not a completely new idea, and it has been around for quite a while in this space. And specifically, a study from 2013 where the authors look at, in that context, different physiological sensing to predict where and what the movement is doing, so that for real-time use, the hand movement and the eye tracking combined together are probably the most suitable combination to actually detect that intention. Still, in that study, it lacked some generalization because it was done on healthy subjects and didn't clearly take into account the disruption of the movement, physical movement intention occurring with patients. And that study also involved some motion triggered by a stimulus. And so it was not natural interaction, in the sense that it's different from a self-paced motion initiated by the subject, which we are interested in. Otherwise, other approaches using gaze often use an explicit feedback, meaning, well, waiting for the person to look specifically in one place at dwell time, and wait for them to confirm that that's where they want to go, which is not a natural interaction. And so for this reason, we look at a way and provide a model to provide a natural interaction, but for people with disrupted movement capabilities. The model that we propose is a probabilistic gaze movement model. And the first idea of that model is to merge but separate the spatial and temporal information. What we do is we look at when the movement starts based on the movement, so velocity threshold of the hand, so the patient can initiate the movement. And once we actually know when that movement is initiated, we look at the gaze information, so the different fixation, where do you look, and the saccades, where do you switch between different targets, just before that movement initiation, saying, well, that's when the information is important. And so by looking at that, we actually cater for disruptive movement as soon as it can be initiated, and rely on the gaze for all the spatial information. How do we extract this spatial information? Well, we use as well here a balance, a mix between two information contained in the gaze, both the duration within one target. How long do you look at a specific target to get that interest in that target, but also how many times you go from somewhere else to that target, which also reflects the intention. The goal of balancing these two and using these two information is to reflect the interest of the person in a specific object. And that's a model that has been validated by my co-authors in other settings, actually board game settings, where they explicitly look at the interest in some areas of the game. All right, so with this information, calculating these fixations between different targets at a specific time dictated by the movement initiation, well, we think that we could actually guess where the person is trying to do. And to validate that, we designed a simple experiment, very similar to the clinical use of this robotic device that we use for upper limb rehabilitation with patients, very similar setting as the clinical setting, where we have a subject, so we have 7 naive healthy subjects, where they actually get to reach the screen at their own pace when they want to touch one of the 3 targets. And we actually look at the gaze, their gaze and their movement with the robotic system recording their movement. And we get them to do 40 self-initiated movements towards targets on the screen, and we record synchronously the gaze and the hand movement. We did 2 different conditions to actually look at how our model capture well the interaction and the intention of the person, their interest to one specific target. The first simple conditions were the free choice condition, 3 exactly identical target, no specific instruction, always at the same in the same place on the screen, so people can go towards the one they want. They don't need to focus or choose any target specifically. They did that for 20 times. And then we did a more realistic scenario where we actually place different targets, namely a cat, a rabbit, and a dog, and ask them to systematically go for the rabbit. So that's a task that requires some active focus to localize and figure out where is the rabbit and to go with it. All right, and when we do that and we apply our little movement intention model on the gaze specifically before the movement intention, taking the movement intention based on the hand velocity, well, what we show is that in the free choice, we can actually guess properly what target people are going for around 60% of the time, which is not fantastic. But a better guess is, and better prediction is happening when people have to focus and actively choose their target, which is what the scenario we are the more interested in. And we reach a prediction rate of 75%. It's probably not sufficient for a clinical application, but it's a good indication that it's a pure model-based system can work in that context. Looking a bit more in detail at the confusion matrix, we can see that not surprisingly, the error occurs close to the predicted target, meaning that there is some spatial resolution of the gaze prediction involved here that should probably be worked on. Again, going a bit more in details, how movement intention and movement initiation is here detected by velocity thresholds, which means that depending on how people decide to move, how fast they decide to move, well, our detection will occur earlier on or later on in the movement. What is interesting to see on the graph, where we see that when the prediction, how far the prediction happens during the movement, we can see that there is no clear pattern actually of better or worse prediction very early or very late in the movement, with good prediction even if the prediction happens very early, as well as good prediction if it happens very late. And so that's a nice indication that early prediction is probably possible and not an issue with that approach. And finally, if you remember, in our gaze analysis, we use 2 different parameters, the saccades and the duration, how long we focus on each target. And looking a bit at the balance between the 2, we see that we can pretty easily choose, the lambda parameter of the balance have no much impact on the prediction. But interestingly, it has an impact if we only focus on only one aspect, where this prediction and this accuracy drops, meaning that considering both these aspects is important. To conclude, we showed that in that model that even if we need a probably refinement of this model to be usable in that context, it is possible to provide a natural interaction using gaze with a model based, as long as it's use a smart fusion of movement and gaze, And obviously, that's something that needs to be further validated with neurologically injured population, as it has not been done yet. Thank you for your attention. If you want to know more, please download the paper or get in touch via email.